In this video, we explore, in a walking tour, the Deutsches Museum in Munich and its Aviation and Astronautics collection. The Deutsches Museum is an impressive place where modern aviation, historic aviation, and astronautics come together under one roof. From early pioneers of flight to cutting-edge jet technology and satellites in space, we will walk you through the highlights and show how each era of aviation and astronautics connects to today's technology. We will get up close to the Junkers F-13, Junkers Ju-52, Messerschmitts, Cockpit Boeing 707, and dozens of other objects spanning early flight to modern air combat to aeronautics. This video is filmed with no background music and pure museum ambience, perfect for viewers, aviation fans, and engineering enthusiasts. Welcome to Deutsches Museum in Munich, the fascinating world of aviation and aeronautics. Between aeroplanes, helicopters, and dozens of other objects, you will see how technology has developed since the 1950s. With the Do-27 multi-purpose aircraft, Dornier was able, after 1945, as the first German aircraft manufacturer, to bring an in-house design into serious production without licensing obligations. From 55 to 64, more than 600 Do-27 aircraft were built, over 400 of them for the Bundeswehr. This versatile aircraft was used, among other roles, as a travel, training, and transport aircraft. The Dornier Do-27 was a single-engine STOL light utility aircraft with a typical capacity of 4 to 6 seats, valued for its short-field performance and practical cabin. It first flew in the mid-50s and was produced in the 60s, serving widely in military liaison, utility roles, and also being exported. The business jet developed by Grob Luft- und Raumfahrt was the first such aircraft to be made entirely from carbon fiber composites. CFRP material is lighter than metal, having survived the equivalent of 20,000 flight hours in testing without material fatigue. The maiden flight of the G180 took place in 2005. The Deutsches Museum received prototype number 1 in 2012. The cabin was designed to accommodate 8 or 9 passengers. However, interest in the project ended abruptly when the second prototype crashed during a test flight in 2006, killing the pilot. The development program never recovered and work on the project was discontinued. Nevertheless, the research work proved to be quite forward-looking. Both Boeing and Airbus use carbon fiber composited construction in their latest aircraft models. Unusual, idiosyncratic, and exotic. This was how the Hansa Jet's forward swept wings with their additional fuel tanks were described at the time. The design of Germany's first mass-produced civil jet aircraft promised good handling properties in slow flight. A spacious cabin and an unobstructed view towards the ground for passengers. When aircraft production was again permitted in West Germany in 1955, Hamburger Flugzeugbau GmbH looked for a niche within civil aviation. In light of the growing economy, a fast business aircraft with a long range seemed particularly promising. But the hope of securing the future of the West German aviation industry was not to be fulfilled by the Hansa Jet. Production was discontinued in 1973 after the production of only 45 aircraft. While the first prototype was lost in an accident in 1965, this prototype served as a demonstration aircraft from 1964 to 1968. Despite civilians being the original target group, the Bundeswehr remained a key customer, using the jet for training and transportation. The helicopter you see here is a Sikorsky S-55. It was designed for 10 passengers and it made its maiden flight in 1949. A radial engine is located in the large, round nose. The Sikorsky S-55 was a resounding success. Starting in the early 50s, the helicopter was delivered to all branches of the US Armed Forces and Coast Guard. Other countries built the helicopter under license. Around 1,600 of these helicopters were produced before production ceased in 1959. Technical innovations just kept on coming. For example, the radial engine was replaced by a more powerful turbine and the three-blade rotor by a quieter five-blade rotor. This made it possible to transport heavier loads. The experience gained in the Korean War led to new tactics in military helicopter operations. This resulted in the development of different types of helicopters, which played a central role in the subsequent Vietnam War. The Sikorsky S-55 on display here served in the US Air Force. It flew search and rescue missions. After the helicopter was taken out of service, it was refurbished for the Deutsches Museum. Since then, the main and tail rotors have been rotatable electrically. This museum aircraft is an AutoGyro Cavalon, a German-built enclosed two-seat gyroplane rover made by AutoGyro GmbH. A gyroplane uses an unpowered rotor for lift. The rotor spins by autorotation as air flows upward through it, and a rear pusher propeller for thrust. Exactly what your photos show: rear prop, big cabin, tricycle gear. The Cavalon is known for its enclosed cabin and side-by-side seating, aimed at touring comfort rather than open cockpit sport flying. The Cavalon specifically is positioned as a touring gyro, enclosed cabin, better weather protection, and higher cross-country practicality than open-frame gyros. With the Bo 105, MBB created the first successful German helicopter of the post-war era. One special feature was its hingeless rotor head. The rotor blades were made of modern composite materials, so flexible that the flapping and lead leg hinges could be omitted. In 1961, the company Belkov and Viking KG set out to build a light twin-engine helicopter of the 2-ton class. The prototype first flew on 16th February 1967. Among the buyers was the Bundeswehr. The BO-105 achieved fame in the yellow livery of the German Motor Club ADAC and in the red and white of the German Air Rescue Service. More than 1,400 units were built in Germany. Production ended after 33 years in 2001. On display here is the fourth prototype, which was converted for various tests, including high-speed testing. Changes included fairing the rotor head and shortening the landing skids. With added lateral stub wings, the helicopter flew 404 kilometers per hour. The A320 cockpit looks efficient and tidy, as menus can be called up on display screens, which can thus take over several functions simultaneously. Pilots control the aircraft's movement with the side sticks using wrist movements. All members of the A320 family and the larger A330 and A340 have the same cockpit equipment and similar flight characteristics. This commonality allows pilots to fly different types with the same type qualification. When the A320 prototype flew in 1987, it was the first airliner to be equipped with digital flight controls, fly-by-wire. Electronic cockpit displays, colloquially referred to as glass cockpits in reference to older CRT screens, had already been introduced. The role of the flight engineer had also been eliminated, so pilots were now sufficient. Bubble canopy, exposed lattice tail boom, skid gear with small wheels, and the 2 saddle tanks above the cabin. The aircraft in the foreground is a Bell 47 light helicopter. The type that in U.S. military service was designated H-13 Sioux. The Bell 47 is widely credited as the first helicopter certified for civilian use. Certification date commonly given as 8th March 1946. The J79 jet engine became one of the most successful military engines for supersonic aircraft thanks to its performance and reliability. Erhard Neumann developed it at General Electric starting in 1952. Around 17,000 J79s were produced over a period of 30 years. In Germany, MTU München GmbH participated in the J79 license program from 1960 onwards. The company did parts supply, assembly and overhaul. After 1970, they developed an improved version of the engine, the J79 MTU J1K. The Starfighter's high accident rate was partly due to technical defects in the engine. Although initial problems with the variable area exhaust nozzle were solved, further aircraft were lost after sudden engine failures. The F-Series was a two-seat trainer version of the Starfighter jet. The NATO deterrence strategy of 1957 called for West Germany to possess nuclear-capable aircraft. The all-purpose F-104 fighter was at the time the aeronautical backbone of the West German Air Force. The air forces of other West European NATO members relied on it heavily as well. After 1970, the type was phased out, replaced by the fighter jets Phantom and Tornado. In the early 1960s, before the single-seat serial version F-104G became available, the Bundeswehr acquired 30 F-104 trainers. The aircraft exhibited here was one of them. It flew at the Air Force Waffenschule 10 in Nürnberg and, starting in 1964, at the air base in Jever, remaining in service until the two-seaters were retired in 1971. German Air Force pilots were first trained on the Lockheed F-104 in the early 1960s in Burbank, California. There they entered a new aeronautical dimension, flying at more than twice the speed of sound. The next aircraft is a Flight Design CT series light sport aircraft. The CT family is a composite light sport aircraft designed for efficient touring and training. The engine is usually from the Rotax 912 family, 100 horsepower class. This aircraft is a two-seater, and the use cases are flight training, touring, efficient cross-country flying. This flight simulator is based on the cockpit of the Diamond GA42NG. It has a wrap-around display screen that gives pilots a 180-degree field of view. The flight characteristics match those of the real aircraft, and the cockpit has all the same equipment as the original. Behind the cockpit sits the flight instructor. He or she can intervene during the course of the flight, changing the weather, for example, or causing certain aircraft systems to fail. This type of simulator is especially suitable for professional training. The flight simulator requires several powerful computers to operate. 5 computers process and render the sound and images. A main computer, the so-called simulation host, coordinates the control inputs and display. The instructor has a computer as well. The extra EA300L is a German-built 2-seat high-performance aerobatic aircraft designed for advanced aerobatics and competition-level maneuvering. The Extra 300 family is known for a lightweight structure optimized for high aerobatic loads, commonly described as a steel tube fuselage with composite metal elements and a composite wing, purpose-built for precision aerobatics. The workstations on display are from the former control tower at Cologne Bonn Airport. The main landing gear of an Airbus A300 has to support weights of up to 64,000 kilograms. The wheels have hydraulic disc brakes made of steel and are equipped with an anti-skid system. The tires are inflated to a pressure of nearly 11 bar. Landing gear is regularly put under heavy stress, in particular during crosswind landings, which can generate extreme forces. To reduce aerodynamic drag, landing gear is retracted into the fuselage immediately after takeoff. The actuator is hydraulic. This fuselage segment comes from the prototype of the Airbus A300, the world's first twin-engine wide-body airliner. It was an early success for the European aircraft manufacturer, appearing shortly after the company's founding in 1970. The innovative aircraft type found a market niche as a short and medium-haul airliner on routes of up to 5,000 kilometers. The fuselage, 5.64 meter in diameter, accommodated 80 seats and 2 aisles per row. This fuselage segment came off the assembly line of the A350, a twin-engine long-haul airliner that flew for the first time on 14th June 2013. The A350 has variants of different fuselage lengths. The largest seats more than 400 passengers. This turbofan is a General Electric CF650D. It is a large, high-bypass, two-spool turbofan with a thrust reverser, used on wide-bodies airliners including the Airbus A300, A310. The F-13 was the first passenger airplane made of metal, a world first in June 1919. The air limousine for 4 passengers was part of the initial equipment of Lufthansa, which was founded in 1926. The more than 300 F-13s built were very easy to repair and flew with slow skids or float even in the remotest parts of the world. The Junkers limousine, also known as the Corrugated-metal limousine, represented the transition to the age of passenger aircraft. It was the first all-metal aircraft developed for civil aviation. The provisions of the Treaty of Versailles banned military aircraft in Germany. Hugo Junkers managed to avoid this fate by building this purely civilian aircraft. This exhibit is a Dornier Libelle flying boat. It's a small single-engine flying boat, not a land plane. It's meant to operate from water. It is high-wing, strut-braced with a pusher propeller. The Libelle line was Dornier's smaller runabout flying boat concept, much smaller than Dornier's big ocean-going boats, designed for practical regional use, lakes, coasts, private owners, and light commercial work. The Klemm L25 was a popular training and sports aircraft. The aircraft, which was built between 1928 and 1939, was designed by the German civil engineer Hans Klemm. Thanks to its forgiving flight characteristics, pilots made a number of record-breaking flights with the Klemm. They could land almost anywhere. They could even fly high enough and fast enough to pass over mountains. This aircraft was manufactured by the German company Klemm in 1935. The aircraft with the marking D779 is a Messerschmitt M17, a German high-wing sports monoplane designed by Willy Messerschmitt and introduced in 1925. It's a light sport touring aircraft. Maximum speed was 140 kilometers per hour. This aircraft is a Junkers A350, a two-seat sports aircraft from the late 1920s, early 1930s. You can also see the typical Junkers corrugated, well-black, duralumin skin, plus the open tandem cockpits and cantilever low wing that match the A350. The A350 is a light sport monoplane, two seats, open cockpit. It's all metal, corrugated duralumin skin, a Junkers trademark. It was basically a sports car of the air for its day, light, metal, modern-looking, and used for record long-distance flights in the early 1930s. Crew, 2 pilots. Wingspan approximately 10 meters. Length 7.1 meter. Maximum takeoff mass 600 kilo approximately. Top speed approximately 172 kilometers per hour. Period figures commonly cited. Range approximately 600 kilometers. This is a Bücker Bü 131 Jungmann. It is a two-seat tandem cockpit biplane trainer with fixed gear and bracing wire struts. It is a basic trainer, also used a lot for aerobatics. It has a welded steel tube fuselage structure with a mixed covering, metal forward, fabric aft. Its maiden flight was on 27th April 1934. Germany adopted it as the main basic trainer for the Luftwaffe. Also, Spain built large numbers under license, commonly referred to as Casa Jungmann, and museums sometimes labeled these broadly as Bü 131 Jungmann because they are essentially the same aircraft family. Early Bücker Bü 131 variants used Hirt inline engines. The Tante U became world famous as a passenger and cargo plane in the 1930s. Its outdated corrugated sheet metal construction dated back to the First World War. At times, the Ju-52 handled 3/4 of Lufthansa's air traffic over Germany. However, this fleet was secretly financed by the military, as the Ju could easily be converted into a bomber. The origins of the Ju-52 date back to the late 1920s. The plane was intended to provide profitable air freight transport for the Junkers Company. The first major military mission carried out by the Ju-52 was the first airlift in world history during the Spanish Civil War. Right up to the end of the war, the Ju-52 was the backbone of German military transport aviation. In 1975 and 1972, the astronauts of the Apollo missions 15, 16, and 17 undertook extended excursions in electric lunar rovers. The two-seat lunar roving vehicle was transported folded up on the side of the lunar module. After landing, the astronauts deployed the wheels and lowered the rover to the ground by pulleys. The three lunar rovers of the final three Apollo missions traveled a total distance of about 90 kilometers. The rover driver controlled the front and rear wheels and the speed with a T-handle pivot. The only navigation instruments were a directional gyro and an odometer. A large parabolic antenna sent images from the TV camera to Earth. The lunar rover could transport about 27 kilograms of moon rock. Most of its payload capacity was taken up by the two astronauts and their spacesuits. The Mercury space capsule was the USA's first manned space vehicle. When on 5th May 1961 Alan B. Shepard became the first American in space, he did so flying in a Mercury capsule. Shepard conducted a brief ballistic flight to an altitude of 186 kilometers. 1 year later, John Glenn achieved orbit in the Mercury, circling Earth 3 times. The capsule was a buoyant, double-walled construction of nickel alloy. The dome base consisted of a massive beryllium plate that served as a heat shield during atmospheric re-entry. The capsule was originally designed without windows. After astronauts protested, a window was installed. The Mercury program was concluded on 16th May 1963 with a record of 6 successful manned flights and no accidents. The Spacelab exhibited here was used by NASA to qualify and test the Spacelab system. It was part of the preparatory phase for building the 2 space labs that alternately flew to space with the space shuttles. A 1973 agreement between the USA and several European countries stated that the Europeans would develop and build a space laboratory. The US Space Shuttle was a largely reusable space transportation system. It carried not only people, but also cargo to and from Earth's orbit. One payload it carried was the European-designed Spacelab. The capabilities of the Space Shuttle ushered in a new era in manned spaceflight. This model shows the shuttle, with its payload bay, doors open, and a Spacelab inside. The doors are, of course, closed during launch. Originally, the 2 built Spacelab should fly more than 100 times into space. Finally, however, only 16 missions could be realized. The J2 rocket engine powered the second and third stage of the Saturn V moon rocket. At the time, it was the largest liquid hydrogen-powered engine in the USA. It remained unsurpassed in power until the completion of the main engines for the American Space Shuttle in 1981. The J2 burned one of the highest energy chemical combinations, liquid oxygen and liquid hydrogen. Yet the most exceptional feature of the engine was its ability to restart. The J2 engine was so successful that in 2007 it was taken out of retirement and updated to create the J2X engine for the new Space Launch System, SLS. This is a scale model of the International Space Station, ISS, on display at the Deutsches Museum in Munich. You can identify it by several distinctive features. The large solar panel arrays, the white pressurized modules forming the central structure, the truss structure, various modules and components characteristic of the ISS configuration. The ISS is not a satellite, but rather a modular space station, a habitable artificial satellite. It's a collaborative project involving NASA, Roscosmos, ESA, JAXA, and CSA. Construction began in 1998 and it has been continuously inhabited. It orbits Earth at approximately 400 kilometers altitude. What you're looking at is not a missile display. It's a size comparison wall of space launch vehicles, rockets, and spacecraft, shown as scale models to compare eras and sizes, from small sounding rockets to medium launchers to heavy lift rockets. This is a standard museum lineup. When you put dozens of rockets on one wall, you instantly see how extreme something like Saturn V is compared to everything else. This is a comparative model display of launched rockets, in German Trägerraketen, and related space vehicles. The large black and white rocket mounted above is styled like a Saturn V type heavy lift launcher, while the smaller models below represent other launcher families from different countries' periods. The Raumfahrt exhibition is structured like a journey into space, starting with early rocketry, then engines, crewed spaceflight, satellites, probes, and Earth observation. And it specifically mentions many models and media interactive stations. The V-2 rocket made use of the first liquid rocket engine to enter mass production. The engine was capable of accelerating the 13-ton heavy rocket to 5 times the speed of sound within a minute after launch. A turbine pump supplied the alcohol fuel and minus 183 degrees Celsius cold liquid oxygen to the combustion chamber under high pressure. The alcohol also cooled the double-walled combustion chamber and kept the temperature below 1000 degrees Celsius. During the Second World War, German engineers in the Army Research Center in Peenemünde developed the aggregate A4 rocket weapon, later called Vengeance Weapon II, or V2 by the Nazis. It was the world's first operational liquid fuel-powered rocket. When carrying a 1-ton warhead, the rocket could reach a target located over 250 kilometers away within only 5 minutes. The German Army Weapons Office constructed a huge research complex in Peenemünde on the Baltic Sea in 1936. But it would be another 10 years before the new rocket technology was ready to go into serial production. The project was led by Wernher von Braun. The large-scale production of the V2 rocket was carried out in massive underground assembly facilities located on the southern edge of the Harz Mountains in Germany, with the help of concentration camp prisoners. Of the 60,000 people who were forced to work there, 1 in 3 never survived. After the war, both the US and the USSR used the expertise gained by German engineers to develop the first nuclear-armed intercontinental ballistic missiles. German scientists were, of course, initially unsure of what to do after the Second World War, and a large group of them led by Wernher von Braun, who had taken refuge in the Bavarian Alps, surrendered to the Americans. The Western Allies and the USSR were very interested in this new technology. So at the end of the war, the victorious powers sought to recruit as many rocket technicians and scientists as possible. They wanted to use their expertise to advance their own rocket research. At the time, it was clear to technicians and scientists that if they had to leave Germany, they wanted to go with the Americans. Ultimately, 1,000 German scientists and their families were allowed to enter the USA. A large number of the scientists remained in the USA. Some returned to Germany, not all of them voluntarily. Eventually, it became more widely known that some parts of Operation Paperclip, in which these German rocket scientists were brought to the USA, were not legal. Some of these Nazis went on to become highly distinguished.